Right now, all around you, on a scale you can't even see, there's a battle going on. It's this constant fight against an enemy that literally never sleeps, an enemy that wants to tear apart everything we build. So today, we're going to dive into the hidden science of how we fight back, using a powerful and often totally invisible weapon, the protective coating. Okay, so let me ask you something. Take a look at these three things: a pipeline buried deep underground, a life saving implant inside someone's body, and a massive ship just slicing through the ocean. They seem completely unrelated, right? But what if I told you they all share one single relentless enemy? Well, the answer is that every single one of them is under constant attack. They're locked in this invisible, never ending battle against decay, a fight against the basic forces of nature that just want to break them all down. All right, so let's actually put a name to this enemy. This brings us to our first big topic, the unseen force known as corrosion. So, what is corrosion really? Well, at its heart, it's just a natural process. It's what happens when materials, especially metals, react with things in their environment, like air and water, and they start to change back into their original, more stable form. Honestly, you can think of it as nature's own recycling program. And believe me, this is so much bigger than just a bit of rust on your bike. The consequences are huge. Corrosion is a massive problem for the economy and a serious safety risk. It weakens our bridges, it damages our pipelines, and yeah, it can even affect the medical implants that are supposed to be saving lives.
Okay, so if this attack is constant and totally natural, how in the world do we fight it? Well, that leads us right to the fundamental solution. We have to build a shield against decay.
The core idea is actually pretty simple and kind of beautiful. If you can't change the hostile environment, you just put up a barrier. You create a shield, a protective coating that physically stands between the thing you want to protect and whatever's trying to destroy it. Now, that sounds easy enough in theory, but here's where the amazing science comes in. I mean, how do you actually apply a perfect microscopic shield to something as complex as a tiny screw or as gigantic as a hydraulic column? Well, if you boil it down, the process basically has three key steps. First up is surface prep. You can't just slap a coating on. The surface has to be perfectly clean, and sometimes it's even roughened up to create these tiny little anchors for the coating to grab onto. Then comes the application. This is the really cool part, where high-tech methods like plasma spraying, which is basically firing superheated material at the surface, or laser cladding are used. And finally, you've got the finishing. The surface is often heat-treated or polished to make sure everything is locked in place and those protective properties are good to go. But here's the thing. A coating isn't just one material. It's more like a huge toolbox filled with all these different specialized solutions. So let's take a little tour of that toolbox and see what modern strategies scientists are coming up with. And this table really shows you there is absolutely no one-size-fits-all answer here. For heavy industrial steel, you need something incredibly hard, so you might use a special alloy with metals like molybdenum. But that same coating would be totally useless against the salt in the ocean. For that, you need something like a cobalt-chromium mix that's literally fused onto titanium with a laser. And then, look at biomedical implants. You can't just wrap a bone screw in metal. You need something soft that the body won't reject, like a hydrogel, which is basically a super sophisticated gel. Every problem needs its own unique shield. Let's just zoom in on one of those for a sec. Protecting a hydraulic column. For years, the go-to was hard chrome plating. It worked, but now we have methods like HVOF thermal spraying. HVOF, that stands for high velocity oxygen fuel. Just think of it like a tiny controlled rocket engine that sprays the coating on at supersonic speeds. It creates this incredibly dense, tough layer. And scientists are constantly comparing these methods, looking at everything down to the microscopic structure to find the absolute best defense for that one specific job. But here's where things get really exciting. We're moving beyond just creating passive shields. We're now entering the next frontier, designing surfaces that are smarter, stronger, and even active. And this quote just nails the shift in thinking perfectly. The goal isn't just to protect anymore. It's to create surfaces that can do multiple things at once. They can heal themselves, they can help our bodies, they can interact with the world around them. So what can a smart coating actually do? Well, get this. Some are now self-healing. They're made with complex polymers that can automatically repair scratches and damage, almost like human skin. In medicine, it gets even crazier. They're not just biocompatible, they can be bioactive. That means they can release medicine right where it's needed, or even encourage our own cells to grow onto an implant. Some are even antibacterial, actively killing germs. This is a whole different world from just a simple layer of paint.
And let's just pause on that word for a second. Biocompatibility. It's such a huge deal. It basically means a material can live inside the human body without causing a problem. You're trying to design a coating that our own immune system sees as a friend, not a foe. That's the ultimate test, right?
So, all of this incredible innovation brings us right back to where we started. This isn't a problem that we just solve once and then we're done. It truly is a never-ending battle. So what's the big takeaway here? It's that whether we're talking about freezing steel to make it stronger or designing advanced gels for medical implants, the fight against decay is this constant, relentless cycle of innovation. It's a hidden scientific war that honestly makes our entire modern world possible.
And that just leaves us with one final kind of mind-bending thought. If we can already engineer surfaces that can heal themselves and that can even help our own bodies heal, what's next? What other impossible materials are waiting just around the corner?